Hey everybody, this is Mr. Sam. We are going to cover another topic in our journey to understand covalent bonding, and this one is all about naming molecules. So this is the second bit of notes that you guys have on Unified Classroom. Um, this is different though than how we named ionic compounds. There's some similarities, but there's definitely some differences. So um, now we have our feet a little bit wet about how to recognize a covalent bond between two nonmetals, and they're sharing their electrons. We've drawn some Lewis dot structures. Now it's time to start using the vocabulary correctly and naming them correctly and actually writing their formulas correctly too. So it's a very short little presentation, and it's not going to be too difficult, I don't think, but there's a couple things you just got to remember when naming them. So let's get started. Now, to name a covalent bond, we get a couple things to keep in mind and push the wrong button there. We call them generally molecules. So you can call a covalent compound a molecule, and that's a good term to use when talking about covalent compounds. Also, remember, there's not going to be a single metal in any of these formulas / names. There's only going to be nonmetals, so that keeps it limited in what kind of elements we see, actually. There are two major types of covalent compounds. They sort of follow different rules, I guess. These are the major types. I'm not even getting into the organic chemistry of this. We'll do that later. The two major covalent compounds, and the naming's a little bit different for both of them. There are acids and non-acids. Acids have their own sort of rules. We'll talk about them later. But the non-acids, which we'll talk about today, are you're going to follow pretty straightforward rules. To tell the difference between the two, I think there's a good way of doing that. Acid formulas will always start with an H. An H means hydrogen in this case. So if you see any compound that begins with an H, you can kind of treat it like an acid in general. Usually it's an H, and hydrogen is bonded to an anion, some kind of negatively charged element, obviously, with some exceptions to the rule, but that's a general rule you can follow. And we'll get to acids later. None of the examples we see today will be acids, because we're going to only learn about non-asset naming. But when we start talking about acids, you'll see kind of a trend with this, kind of a, not trend though, a kind of a, I guess, way that this acids always appear. So let's talk about non-acids first, because these are the ones you're going to kind of most, I would assume. The difference between covalent compounds and ionic compounds is that covalent compounds will use prefixes in their names to actually tell you the number of atoms of each element. If you remember with ionic compounds, the name like sodium chloride didn't tell you anything about how many sodiums and chlorides you had, or calcium bromide didn't tell you how many calciums you had or how many bromides you had. Even though in that case you have two bromides, you have no idea just looking at the name. The rules are different when it comes to covalent compounds. There's two exceptions where you would not use a prefix, though. These exceptions are going to be the rule here. First of all, just like with our binary compounds for ionic compounds, these are going to be binary for the most part covalent compounds with only two elements involved. So if there's only two elements involved, there's two names. The first element never uses the mono prefix. Mono means one. So if the first element in your compound, there's only one of them, you don't use the word mono in the beginning. It's just understood. That's kind of the first rule. We'll see that a couple times. The second rule is much more obscure, but it does happen every once in a while. This is kind of a weird one, because if you have a gas that starts with H, so we just said a bit ago that H kind of is a good signal that this might be an acid. But if it's a gas, so I would have to tell you it's a gas. Usually I put a little parentheses G behind it, which stands for gas. And it begins with a hydrogen. There's no prefixes in any part of the name. And I'll show you an example of that. And you're not going to see many of these, but if it has an H in the beginning and it's a gas, don't use any prefixes. Just use the root words, the element names. So we'll see examples of these two exceptions, but they're kind of important to keep in mind. So let's go with the prefixes first, and these are pretty standard prefixes, so I don't think there's going to be much confusion for these. Mono means one, obviously. Di, in this case, is going to mean two. Tri, three. Tetra, four. Penta, five. Hexa, six. Hepta, seven. octa 8, nona 9, and deca 10. So those are your 10 prefixes we would use, and most of you are familiar with them from previous experiences with numerical prefixes, especially maybe in geometry class and things like that. If you're taking geometry, like an octagon has 8 sides, that kind of thing. A pentagon has 5. So I mean, you've heard of these words before. If you're in biology, a tetrapod has 4 legs. So tetra means 4. Triangles, 3 sides. I mean, or 3 angles. Sorry. It's one of those things that you're familiar with these. Now we're just going to use them in chemistry class. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Now the asterisk ones, mono, tetra, penta, hexa, hepta, octa, nona, deca, those, when you use those prefixes, if you are using that prefix with an element that begins with a vowel, like oxygen. Oxygen is one very good example because it begins with an O. You basically leave the final vowel in the prefix off. So like for mono, it's not monoxide with 2 O's, it's monoxide with 1 O. Or it's not octaoxide, it's octacide. I mean, you just leave off that vowel. You don't put 2 vowels in a row, basically. If the element begins with a vowel. So you basically the ones with the asterisks, you leave the final vowel off of the prefix. And we'll see examples of that. Monoxide is probably the most common one using that. Okay, let's name some. There's 5 parts to it, and I think I'm going to go over the 5 parts, the 5 rules of this, but when you start doing examples, it's going to be so much easier. And we'll do a couple of examples. First of all, you put the prefix for the number of atoms of the first element, unless it's mono. You don't write mono first. No covalent compound begins with the word mono. So you put the prefix for the number of atoms of the first element, and then you write the full name of the first element. Much like ionic compounds, you write the full name of the element of the first part of the binary compound. So, for example, you would put dihydrogen, or dioxygen, or fluorine, which doesn't make sense, but the full name. Then you put the prefix for the number of atoms of the second element. However many of the second element you had, you put that prefix. And then the root of the name of the second element. And then just like with the ionic compounds, you're going to end in IDE. So the second word always ends in "ide." That's the suffix for the last word of the 2 words of the binary compound. Those rules are important. They're in your notes. You can look at them. But let's just, I think examples are the key to how to understand, how to name a covalent compound. So some examples. NO2. Both of them are nonmetals. Binary compound, 2 elements. There's 1 nitrogen and 2 oxygens. So we would call this nitrogen. Notice how we don't put mononitrogen because there's only 1 of them. We never begin the word with a mono. Dioxide. So that's called nitrogen dioxide. 1 nitrogen, 2 oxygens. And notice the oxygen basically has the IDE ending at the end. So that's what nitrogen dioxide. CO. CO, and you've heard this one before, I'm sure, is carbon monoxide. Notice how we took the O off the mono because we don't want 2 O's in a row for oxygen. So it's carbon, 1 carbon, no mono in front of carbon because the first word never gets mono, and monoxide, mono, 1 oxygen. So carbon monoxide, oxide is the O. P2O5, we have 2 phosphoruses and 5 oxygens. So we have diphosphorus. We do use the prefix here because it's not mono. There's actually more than 1 in the first one, so we have to use the prefix. Diphosphorus, the whole word, phosphorus. Pentoxide. We drop the A because this begins with a vowel. Diphosphorus pentoxide is the actual word. Next one, CCl4. CCl4, well, C, there's 1 carbon and 4 chlorines. So if we only have 1 carbon, it's not monocarbon, it's just carbon. And then 4 chlorines, if you think about the prefix for the number 4, it's tetra. So it's carbon tetrachloride. Carbon, 1 carbon, tetrachloride. Tetra meaning there's 4 chlorines, and ide at the end. And finally, this is the exceptional one. Begins with H, and it's a gas. I have to tell you that. Well, this is then, you don't use any prefixes if it's an H in the beginning and it's a gas. So no prefixes at all. It's just hydrogen sulfide. You still use the IDE, just don't use prefixes. So it's not dihydrogen sulfide like you would think it is, or actually you would think it would be dihydrogen monosulfide. It's actually just hydrogen sulfide as a gas. No prefixes there. So that's kind of the key. So those are your examples. It's not too difficult as long as you have your prefixes in order and you understand the basic rules and the basic exceptions to those rules. So if you guys have any further questions, please send them my way. And I hope you enjoyed this lesson on naming simple binary covalent compounds. Thank you guys, and you guys have an absolutely wonderful day.